In this video, we're going to be talking about graphing transformations of two trig functions, the sine of x and the cosine of x. So first thing we'll do is we will just review the parent functions and then the key features of each of the parent functions. So first let's look at the graph on the left. This is the graph of the sine of x. And beneath it you'll see a parent function table that gives increments in pi halves. And the y values that go with each of these theta values are listed there in the blue. So let's just talk about some key features of the parent graph of the sine, and then we'll talk about how we would change each of those things in the equation. So as far as a vertical shift goes, in the parent function there isn't a vertical shift. The amplitude, if you'll remember, is the distance that you can go up and down from the midline. So I'm going to draw the midline in a solid red, and then in these dotted lines, I'm going to draw in how far up and how far down my graph can go. So your amplitude is your distance that your graph goes from the midline. So in this case, your amplitude is 1. Your b is the value that would change the period, and in this case our b is just 1, which means our period is 2 pi. So unless your b value is something other than 1, your period is going to be 2 pi. And remember, the period is how long does it take for your graph to complete a full cycle. So in the sine, it's how long does it take the graph, if it starts at the midline, to go up and hit the high point, down and hit the low point, and then back to the midline again. That would be one complete period. A phase shift is how far to the left and right you're going, and in this case, again, I'm not shifting it at all to the left and right. So let's answer the same sorts of questions for the cosine. So the cosine graph looks very similar to the sine graph, but instead of starting at 0, 0, we start at 0, 1, go down, and then come back up. The cosine parent function table fills in like that. And then as we start looking at the key features here, we are going to look at these key features, and let's practice using the equation of the cosine to determine what these key features are. So if my function is just f of theta equals the cosine of theta, my vertical shift would be what numbers am I adding or subtracting on the end of my equation. And in this case, since I'm not adding or subtracting anything, there's no vertical shift. The amplitude is the number that's in front of your cosine. So what number are you multiplying the cosine by? Which in this case is 1. Your b value is the value that I'm multiplying my theta by, which again is in this case is 1. And to find my period, I always do 2 pi divided by b. So 2 pi over 1 is just 2 pi. So that's going to be the period that I'm going to get here. And the phase shift is anything that I am subtracting from the cosine, from the theta that's inside the cosine. So a phase shift would be inside parentheses. In this case, we don't have any. And you could also find all of these key features looking at just the picture on the top. I just wanted to have some practice using the equation to find those key features as well. So let's go ahead and talk about how you would do transformations if you've got a bunch of different transformations that you're dealing with. Okay, first thing you're going to do is you're going to look at reflections. So if you've got a negative that's in front of your sine or cosine, that means you're going to reflect it. That just means it's going to flip upside down. Okay. The amplitude is going to potentially cause a vertical stretch or shrink. And when we talk about amplitude, it's always going to be positive. So we always think about the amplitude as the distance from the midline to the high and low point of the graph, and so we're just always going to think of it as a positive value. Your b value, that's going to cause a period change. And a period change looks like a horizontal stretch or shrink. A vertical shift is a number that you're adding onto the end of the graph, to the end of the function, and a positive number would move the graph up, and a negative number would move the graph down. A phase shift is synonymous with a horizontal shift. We just call them a phase shift when we're talking about sine and cosine. A positive number would move the graph left, and a negative number would move the graph right. This kind of seems opposite of what you would expect, but that is what happens with phase shifts. So let's go ahead and look at this general form of the equation. This, I would say, is going to be a really helpful tool as you start identifying what transformations have happened to a function. So this sine right here, first of all, that could be a cosine, and it would cause the same, it would result in the same situation. So the a in front is going to affect the amplitude, the b is going to affect the period, the c is going to be my phase shift, and the d is my vertical shift. So one thing that we'll be doing today and then throughout the assignment is just identifying what's a, b, c, and d, and then once we know what they are, what do they do to the graph? Before we jump into that, I want to talk about one more key feature of the graph that we haven't talked about extensively yet, and that is the range. So the range, remember, is your y values. So it's how far up and down can my graph or can my function go. And when we're looking at range with sine and cosines, we really only need to look at the amplitude and the vertical shift. So let's go ahead and practice doing that with these two graphs that I've drawn here. So I'm going to do the range for the blue graph first. So if I'm looking at the blue graph, I need to look at the high point. So the high point seems to be this value like on the top of that mountain, which is at 1. Okay, and there's no other values that go higher than 1. So if I'm doing the range for this, then the biggest value I'm going to reach is 1. The smallest value I'm going to reach is -1. So that is the range of the blue or the smaller graph. Let's do the same thing for the red graph. So again, I'm looking for what's the smallest point and then what's the biggest point. What's the highest I can go, what's the lowest I can go. You'll notice that the lowest that you can go is -3. Those are these points down here, kind of at the bottom of the valleys. So that's going to be the first part of my range. And the highest point I can get to is 3. Remember that when you're writing range, you should always have your negative or your smaller number first, and then the larger number. So always think about going like from the bottom to the top. Okay, let's do some examples. Okay, so first thing I need to say is that I accidentally put a K in these notes. You should change all these K's to D's. Okay, sometimes people use K to represent the vertical shift, but in the original equation that we're dealing with, this general form, we're using a capital D. So if I want to graph f of theta equals 3 sine of theta plus pi halves. First thing I'm going to do is identify any of the changes that might be happening to my graph. So vertical shift, I actually have none because there's nothing that's being added or subtracted at the end of my function. The amplitude is 3. Okay, so that tells us how far up and down I can go from my midline. The phase shift is going to be pi halves. And in this case, since I'm adding pi halves, I'm going to be shifting to, not to the right. I made a common mistake. If you're adding, it means that you are shifting to the left. The period, I'm going to do 2 pi divided by the number that I'm multiplying by the theta, which is just 1. So the period is 2 pi. And then for the range, I'm actually going to draw the range in using some dotted lines over here on the right. So we'll come back to the range in just a second. What I want to do is come back to the vertical shift and the amplitude and use that to sketch in kind of the high and the low points of my graph. So since there's no vertical shift happening here, it means that my midline is going to be here at y equals 0. Since the amplitude is 3, it means that from that midline, I'm going to be able to go up to a max value of 3 when I'm graphing this. I'm going to be able to go down to a minimum value of -3. So as I start creating a table and sketching this graph, my entire function should fit between those two dotted lines. Having these dotted lines also makes it really easy for us to identify the range, because the lowest value I'm going to get to is -3, and the highest value I'm going to get to is 3. Okay, so let's go ahead and fill in this table down here, and then we will plot some points and make a rough sketch of this graph. First thing I'm going to do is in these kind of shaded in boxes, I'm going to just put the values of my parent function. So my theta values, which are going to act as my x values, are going to go up in increments of pi halves. And then my sine values of my parent function are 0, 1, 0, -1, and 0. So now what I need to do is I need to find my new x values and my new y values. So one thing that I'm going to think about is that the things that affect my y values, that's a vertical shift and an amplitude. So these two things up here, that's going to affect my y values. My phase shift and my period, those are going to affect my x values. So let's start by finding our new y values. Okay, so I know that I have a vertical shift of nothing and then an amplitude of 3. So that means that I'm not going to be adding or subtracting anything to my y values, but I am going to be amplifying them by 3, which means I'm going to multiply all my y values by 3 so that the amplitude is 3. So 0 times 3 is 0, 1 times 3 is 3, 0 times 3 is 0, -1 times 3 is -3, and then 0 times 3 is 0 again. So those are my new y values. And again, I use the vertical shift and the amplitude to get my new y values. To find my new x values, I need to look at the phase shift and the period. So the phase shift is telling me that I need to shift all of these x values, or all of these theta values, to the left pi halves, which means that I'm going to subtract pi halves from all of my x values. The period hasn't changed. At 2 pi is still kind of the original period, so I don't need to worry about doing anything to change the period. So I'm just going to take all my theta values and subtract pi halves. And I'll get these values. And maybe you need to take some time and actually write out the subtraction problems for these, and that's totally fine, but you should get these values. Okay. And then I can just use the new x value and the new y value to graph these points. So at negative pi halves, I have a value of 0. Okay. At 0, I have a function value of 3. Pi halves, I'm back at 0. At pi, I'm at -3, and then at 3 pi halves, I'm at 0. So one complete period of this sine wave looks like that. Now remember that when you're graphing, you always want to graph at least 2 complete periods. So I need to basically mimic these points, kind of iterate them again so that I get another, period. So I'm just going to kind of know that I'm kind of going over in increments of pi halves to mimic these points. I'm just going to fill in as many as I can on this graph. Okay. And so this graph, remember, should look very repetitive by the end of it. Right, so you should just be getting the same thing over and over again. So that is what that sine wave would look like. Okay. All right, let's go ahead and look at another one. So here I have the cosine of 4 times theta minus pi over 4. So my vertical shift, that would be how far up and down I'm going, which would be affected if I had a number added on to the end here. Since I don't have anything added on, I don't have any vertical shift. My amplitude is the number in front of the cosine, which again here, don't really have anything, it's just 1. My phase shift is that number that I'm subtracting from my theta, so it's pi fourths. And since I'm subtracting, it means that I'm going to the right. And then to find my period, I would do 2 pi divided by 4, which is pi over 2. Okay, so let's go ahead and figure out what our range is by drawing in our midline and our dotted lines for the amplitude. So since there's no vertical shift, my midline is going to remain at y equals 0. And since the amplitude is 1, it means that my high and low points of the graph are just going to be up 1 and down 1 from the midline. So that means that my range is from -1 to 1. Okay, let's go ahead and fill in our parent function table. Hopefully by now you have this pretty memorized. You've been filling them in a lot throughout these assignments if you've been following along and keeping up. And again, those shaded values, we are not going to necessarily plot those points. We are going to use them to perform any of the transformations that we need to. So let's start with our new y values, which are going to be affected by the vertical shift and the amplitude. Now if you notice, the vertical shift didn't change and the amplitude is still 1, which means that my y values are going to remain unchanged. So I'm just going to copy them down so that I need to know that these are my final y values that I'm going to be using. Now my x values, those are going to be changed quite a bit. So with my x values, I have to shift them to the right pi-fourths, and I need to divide them all by 4 so that I get an amplitude, so that I get a period of pi-halves. So I'm going to start by taking all of my theta values and dividing them by 4, and then adding pi-fourths to them. So if I take 0 and divide it by 4, 0 divided by 4 is 0. And then if I add pi-fourths, I'm going to get pi-fourths. Okay, let me work out the next one down here. Say I have pi-halves, and I divide it by 4 to take care of my period change. That's going to turn into pi-eighths. Then I need to take the pi-eighths, and I need to add pi-fourths. Now I can't just add pi-fourths and pi-eighths because I don't have a common denominator. So I'm going to go ahead and create a common denominator by multiplying pi-fourths by 2 over 2. So I get pi-eighths plus 2 pi over 8, which is equal to 3 pi over 8. And that is my new theta value. Okay. So with my next one, I'm going to take pi divided by 4, which will be pi-fourths. Then I'm going to add pi-fourths, which is going to turn into 2 pi-fourths, which is pi-halves. The next one will be 5 pi over 8. And then my last one will be, let's make sure I'm doing this right, 3 pi over 4. Okay. Now let's talk about these. These ones are kind of tricky to get, these new x values. So it might take you some time to figure out what those values are. I'm also going to show you another way to get these points on the graph that might be a little bit easier for you. So I am just going to look at where my period starts and ends, as well as how long my period is. So I know that usually the cosine period starts at 0. Since I'm shifting it to the right pi-fourths, my period is now going to start at pi-fourths. Okay. I also know that my period is pi-halves in this case. So that means that to complete a full cycle of the cosine, it's going to take me pi-halves, which is 2 tick marks on this graph, so it brings me over to right here. Okay. And then I just need to fill in the rest of the cosine cycle here. So if you think back to your original cosine parent function, you have your 2 kind of starting points up here. And then right in between those, you have your low point. And then right in between your high and low point, you cross your midline on both sides. So we're going to use that thinking to fill in the rest of the points on this. So I have these 2 high points. Right in between those, I'm going to hit my low point. And then right between the high and the low point, I'm going to hit my midline. Okay. So that allows me to graph a full cycle of cosine. Now I'm going to want to mimic those points again to complete at least one other cycle. So I'm going to do the same thing. I know that if I start on this far left point that I have, and I want to if I want to create a period to the left of it, I would need to go over to pi-halves to reach another high point. Right in between those points, I would hit the low point. And then between each of those high and low points, I would hit the midline. So there would be another cycle of my cosine graph. And I could just keep this going however long I wanted. Okay, but since I've graphed 2 complete cycles, I am going to call it good right there. So hopefully that was helpful to see another way to get that graph, actually on your graph. All right, this one is a doozy. So let's take a look at this one and make sure we feel comfortable doing it. So vertical shift is this number that we're adding onto the end. So here I am moving up 1. My amplitude is the number in front of my sine, so it's 2. The phase shift is how far left and right I'm going. So it's pi. Since I'm subtracting, I am moving right. And the period is 2 pi divided by 1/2, which is 4 pi. With ones like this, where you have a lot of transformations happening, I would highly recommend drawing in your midline and your high and low points so that you make sure that you get your graph in the right spot. So my midline is going to be shifted up 1. So my midline is at 1. Another thing to be really cautious of is that you need to make sure you're looking at the scale on your graph. So here, my y value is just going up by increments of 1, even though I'm only writing the even numbers, okay? Then since the amplitude is 2, it means that the highest I can go is 2 up from the midline, or up to 3. And the lowest I can go is 2 down from the midline, so down to -1. So using just that, I'm able to identify the range. I can go from -1 to 3. So let's go ahead and fill in our parent function tables, and then we're going to start adjusting our x and y values based on what transformations are happening here. So let's start with our y values. So again, for the y values, I'm just using my vertical shift and my amplitude. And you do need to do your amplitude first. So amplitude of 2 means I'm going to multiply all of my y values by 2. And then I'll do my vertical shift. So I'll move it up 1. So I'm going to take my y equals 0, multiply it by 2, and then add 1 to get 1. 1 times 2 is 2 plus 1 is 3. 0 times 2 plus 1 is 1. -1 times 2 plus 1 is -1. And then here I am back to 1. So this bottom row is my new y value. So if you're confused about how I got that, what I did is I basically took my original y value, I multiplied it by 2, and then I added 1. So 2y plus 1 is kind of the formula I used to get this whole row. Now let's look at our phase shift and our period. So these are going to allow me to do my x values. Let me go ahead and switch colors just because these are going to be a little bit more extensive. Whoops. Okay. So if I'm doing my x values, my period is 4 pi and my phase shift is pi. That means that with each of my theta values, I first need to divide it by 4. That will get me, sorry, not by 4. Divide it by 1/2. And then I need to add pi. That will get me the phase shift. Now I'm actually going to write this a different way because dividing by 1/2 is the same thing as multiplying by 2. So 2 theta plus pi is basically the equation I'm going to use to get these new the new theta values. So I'm actually going to show my work for all of these just so that we are pretty confident getting those new theta values. So it's going to be, if I take my first theta value of 0, I'm going to do 2 times 0 plus pi, which is just going to be equal to 0 plus pi, which is equal to pi. So that is my new x value here. If I take pi halves, I'm going to do 2 times pi halves plus pi. The nice thing is that these two 2's will cancel out, and I'm just left with pi plus pi, which is 2 pi. That's my new x value there. If I take pi, 2 times pi plus pi is equal to 2 pi plus pi, which is 3 pi. We have 3 pi here. You'll be starting to see a pattern. Each of these x values is going to go up by an increment of pi. So we have pi, 2 pi, 3 pi, 4 pi, 5 pi. And these are my final x values. Now let's look at my graph really fast. You'll see that on my x-axis, I really only have enough values to plot up to 2 pi. So I will not recommend doing this on the homework. In fact, I will make sure that your homework is set up nicely so you don't have to do this. We are going to change the scale on this. So I'm going to make these, instead of each of these tick marks going up by pi halves, I'm going to make them go up by pi. So 1 pi, 2 pi, 3 pi, let me just write this underneath, 4 pi. Same thing over here. This would be negative pi, negative 2 pi, and then negative 3 pi. Okay, and the reason I want to do this is because then we can graph a little bit more of our actual values on this graph. So new x value. So at x equals pi, my y value is 1. At x equals 2 pi, my y value is 3. At x equals 3 pi, my y value is back to 1. At 4 pi, my y value is negative 1. And then if we had a 5 pi, it would be back at 1. So I'll just kind of draw that in right there. And then as you sketch this out, there's your first cycle of pi. Sorry, of this sine wave. Now again, I always want to do 2 cycles, so let's go ahead and duplicate these points on the other side of my graph so that I can have another complete sine wave here. And then with 2 complete periods or cycles, that graph is completed. Okay. So once like this, where there's lots of transformations happening, take your time, write the points out, write all of this work down here out if you need to, right? Get a piece of scratch paper and work it out. And one way to just check and make sure your answer is right is that at the end, your graph should have you should be able to recognize all of these transformations in your graph. So you should be able to see that the graph has moved up 1, the amplitude is 2, it's been shifted to the right pi, and the period's been lengthened.